Hey guys, today I'm going to solve a problem from magnetic force. So here's our question. This question basically describes this figure right here. It says that we have a horizontal metal bar that is moving down with a velocity v. This horizontal metal bar is in electric contact with these two vertical metal bars, which are in turn connected with this voltmeter, and the distance between two vertical bars is w, and this whole system is inside a uniform magnetic field that is coming out of the paper. And the question is asking what is the voltmeter reading when this horizontal bar is moving downward. It says give the magnitude and sign. So in order to solve this problem, first we need to consider what is happening to this horizontal metal bar, or you can just say that what is happening to the charges inside the horizontal metal bar when it moves downward. So the charged particle in the bar are moving downward within the magnetic field. That means the charges inside it experience the magnetic force. Many of you must be thinking, what kind of charges? Well, for this question it doesn't matter which charge you pick. I'm usually used to positive charges. I mean, you can take whichever charge you want. For me, for this question, I'll take positive charges. So let us say that there are positive charges inside this metal bar, and they experience the magnetic force. So now, by using the right hand rule, we can find out the direction of the magnetic force on those charges. The magnetic field is coming out of the paper and the horizontal bar is moving, so the magnetic force will be on the left hand side. And I drew a little diagram that shows the charge distribution and the forces on the charges inside the horizontal metal bar. As you can see here, the positive charge is on the left, negative charge is on the right, and the magnetic force is acting on the left, and we have electric field on the right. So when this moves down, the polarization takes place, but it takes place for a very short period of time. And when the polarization takes place, the net force on each charge is zero. That is, the sum of magnetic and electric force is zero. And for the magnetic, we have the formula QVV sine, since this is perpendicular to the magnetic field, so 90 degree is equal to QE. From here we can solve for the electric field, and since we are considering that electric field is uniform through the bar, we can calculate the potential using this formula. Delta V is equal to negative integral of EdL. So we have the width, the distance between two horizontal bar is W, so VVW, and by plugging the values we get our magnitude. For the next part of the question, as I have drawn here, you can see that the left end of the bar is at a higher potential. That is, all the positive charges are here and all the negative charges are here. And if we look at the original diagram, the question, our right hand bar is connected to the negative negative terminal of the voltmeter. So we have higher potential and the negative, which is connected to the negative potential, so our voltmeter reading will be negative. Once again, we need to consider that this polarization, whenever this horizontal bar moves down, takes place for an extremely short period of time. So this voltmeter, whenever it goes down, this voltmeter will instantly give you a reading which will be a negative. So our value is delta V is equal to negative 0.1125 volts. Thank you.